Dear Professor, dear cost accounting class, today we're looking at the F-35 program and how job costing and cost accounting shaped its profitability. It's a huge complex project and a great example of what can go wrong when costs aren't properly managed. Here's what we'll cover. A quick introduction to the F-35, why the case matters for cost accounting, what went wrong, how unit costs and life cycle costs played a role, and finally our key takeaways. The F-35 is a multinational project to build one advanced jet for several military branches and allied nations. The idea was to reduce costs by sharing the technology and production, but the reality became far more expensive than planned. The F-35 had several goals. Build one versatile aircraft for the Air Force, Navy and Marines, replace the older aircraft like F-16, A-10 and F-18, reduce long-term costs through shared design and components, and improve the interoperability among NATO allies. Some key facts are that the program launched in the early 2000s with a planned life cycle cost exceeding 1.7 trillion. There are three variants, A, B, and C, and numerous international partner nations. So what happened? Total life cycle costs skyrocketed to over 1.7 million. A combination of design complexity, constant rework, and supply chain disruption drove costs far beyond the original budget. From a cost accounting standpoint, this case is extremely valuable. Job costing and overhead allocation were inaccurate. Unit costs and estimation became unreliable, and the indirect costs were misallocated. Cost tracking systems failed to detect overruns early. This is a perfect example of how inaccurate cost data can underdetermine the entire project. Regarding the job costing, the F-35 program was treated as one large job with three subjobs, the F-35A, B, and C. Each variant had its own direct material, direct labor, and specific overhead requirements. Job costing helped track these specific costs, for example, the lift fan system unique to the F-35B, the carrier-based wing structure for the F-35C, and the international cannon for the F-35A. The goal was cost visibility, understanding how each version different costs. Regarding the cost tracing and cost allocation, the direct costs could be traced easily to each variant, but indirect costs became a major problem because a large portion of shared R&D, software development, global coordination, and redesign costs had to be allocated across all aircraft. Because these indirect costs were high, allocation blurred the true unit cost of each variant. This made the cost control more difficult and reduced the accuracy of cost-based decisions. Regarding the importance of unitary costs. Unitary cost, the cost per aircraft, is one of the most critical metrics in this project. If the unit cost is too high, partners nations cannot afford to buy the aircraft. This reduces demand, which in turn increases the cost per unit even more, which just ends up in a negative feedback loop. Lower unit costs improve export potential and allow development costs to be spread over more aircraft. Accurate unit cost estimation is therefore very essential for pricing, the budgeting, long-term profitability, as well as the program's struggled with political and military support weakened. Regarding the impact of the unitary costs, the consequences of these rising unit costs were significant. For once, there was the problem that struggled to reach its planned sales volumes, the partner nations, which faced increased pressure on their defense budgets, and the misestimated unit costs contributed to delays and reduced project profitability. So unit costs ultimately shaped both the financial and the political trajectory of the F-35 program.
Now let's look at what actually went wrong with the F-35 project. Several major factors contributed to the massive cost overruns. First, the design was extremely complex. One aircraft had to replace multiple legacy jets, which increased engineering uncertainty and made unit costs hard to predict. Second, the project involved new and advanced technologies, especially stealth systems and highly sophisticated software. Because these technologies were still evolving, estimating material and labour costs became very difficult. There were also major coordination issues. Production was spread across multiple countries and suppliers, which made communication challenging and created delays in rework. Then came testing and rework problems. Frequent testing failures demanded redesigns and adjustments, which pushed labour and overhead costs even higher. And finally, changing requirements made cost forecasting unreliable. As design needs shifted, the cost structure kept changing too. All of these combined to create a perfect storm of rising costs and extended schedules. Now, this slide looks at the problem from a management accounting perspective, how cost control weaknesses translated into profit and performance issues. Firstly, there were cost estimation errors. Early unit costs were far too optimistic. Engineers didn't fully factor in design complexity or the global coordination effort required. Next, overhead allocation was mishandled. Indirect costs such as logistics, testing, infrastructure, and software development weren't allocated correctly. This means the true cost per aircraft wasn't visible early enough. Next, the program suffered from life cycle costing failures. Most of the attention went to production cost, not long-term expenses like maintenance, training, and upgrades. Those long-term costs were underestimated, reducing future profitability. And the consequence, a major profitability impact. By 2014, the project was already 163 billion over budget and 7 years behind schedule, which severely eroded margins and required external funding. The key takeaways here are accurate costing is essential for profitability, poor cost tracking makes financial outcomes unclear, effective cost control and realistic planning are not negotiable for large-scale projects. Bringing everything together, the F-35 case shows us three major lessons. Firstly, inaccurate cost estimates and poor overhead allocation were major contributors to the overruns. The project simply didn't have a reliable early-stage costing foundation. Next, life cycle costs were often ignored, which reduced long-term profitability. Maintenance, training, and upgrades can sometimes cost more than the aircraft itself over its lifetime. Third, delays and budget blowouts forced the program to rely on external funding, which weakened financial sustainability. So the key message here is that strong cost control, realistic planning, and accurate costing are absolutely essential for any large-scale project. Whether in defense, infrastructure, or technology, these principles determine whether multi-million-dollar and even multi-billion-dollar projects succeed or fail.
Now we're going to be talking about the life cycle costing on the F-35 aircraft. Life cycle costing evaluates total ownership costs across an aircraft's full lifespan development, acquisition, operation, upgrades, and disposal, as well as its 50-plus year service life, requiring long-term multinational cost planning. So this is divided into sectors, and I'm going to go one by one briefly. So we have R&D and development, which is a multi-billion-dollar testing and design program. For acquisition, they decrease unit price through scaled production. For operations and maintenance, there are larger cost shares. This is because of the advanced systems and stealth sustainment. For training, obviously pilots, technicians require specialized ongoing training. For upgrades and software, constant modernization and mission system updates are needed. And for end-of-life disposal and environmental handling, that is also, again, well needed for the cost, and you need to take note of that. And for total life cycle cost, it's estimated around 1.7 trillion, which is majority from sustainment, and $36,000 per flight hour demonstrate the cost burden of long-term operations. So this type of costing ensures governments measuring the true affordability of the aircraft and the flights, also comparing the alternatives, and also applying the cost control strategies, which are shared maintenance, predictive analytics, and standardized logistics. Now, the lessons learned about the whole entire F-35 aircraft in cost accounting, and from our presentation, we found out that there are poor cost estimation and unrealistic timelines, which led to massive overruns and delays. And weak cost tracing and heavy cost allocation obviously hid the true cost per aircraft. And complex design and constant redesigning caused expensive rework and production inefficiency. And lack of accountability and weak cost control systems allowed issues to escalate unnoticed, therefore adding up to unnecessary costs. Ignoring life cycle costs, which is what I previously just mentioned, meant long-term sustainability and maintenance were underestimated. Never overestimate. Overall, continuing without accurate costing and strong oversight, even advanced innovation becomes financially unsustainable. Now I'm going to be explaining the key takeaways. So let's start with accurate job costing is very essential for the F-35 aircraft in a large scale, along with complex projects to maintain transparency and control over spending due to its specific material. Its cost will obviously overpower its production, therefore needing control. Strong cost control mechanisms and forecasting tools are needed, such as like ABC, target costing, life cycle costing, as I just explained, to help prevent runway overruns. The F-35 case basically demonstrates that successful innovation requires disciplined financial oversight and realistic planning. Cost tracing and allocation must be clearly distinguished because excessive cost allocation can hide the true cost per unit and weaken decision making. And obviously, due to poor early estimation and continuous redesigns, it contributed to more than $163 billion in overruns and major profitability reduction. The F-35 program demonstrates that without accurate costing, realistic planning, strong oversight systems, financial performance collapses, even when the technical innovation succeeds.
To wrap up the presentation, here are a few questions for discussion. Firstly, how could better cost estimation and project tracking have prevented the F-35 overruns? Think about the tools like activity-based costing, earned value management, or more accurate overhead assignment. Next, is the F-35's high cost justified by its strategic performance and capabilities? This brings up questions of national security, long-term value, and opportunity costs. And lastly, what management accounting tools could help control costs in large defence projects like this? Consider things like life cycle costing, target costing, continuous forecasting, or risk-adjusted budgeting. These questions help us connect the F-35 case back to core concepts in management accounting and cost control.